Okay, so we're going to continue with 7.2, and this is when he finally explains U substitution in the notes. I don't know if I'll even really go back to it. And there's definitely a need for it. And then the reason why I have to go over number 10 is because there's a slight change when we do a definite integral, which is not in the notes, which is why I'm just going to jump to a homework problem. I believe there's a second one where you have to practice it. So make sure you understand what to do with a U substitution and a definite integral, opposed to just these plus C problems. So the same thing really happens here with the inner function being 2x minus 1. But if I were to do the derivative of that, it's just 2. And this is what he was getting at, is that 2 is not part of the non-part. So that's why he writes down no. So it's not attainable by multiplying the integrand by a constant to get rid of that number, which is what he does on the previous page. But again, I don't really teach it that way. So if we were to practice this problem, what we would have to do is still do the same thing, that U equals 2x minus 1. So then du would be equal to 2 dx. And he does the same thing that I do, where you solve for dx, which would be 1/2 du. But just like what I do before, what the next step is just rewriting that entire integral as x times u to the third power, and then replacing dx with that 1/2 du. So what we need to do is think of a way that we can get this entire integral in terms of only u. And I know that there's this number 3 down here, but I'm actually going to do this up here because it makes more sense in my mind. So let me write down number 3, is we can get rid of this x by looking at this equation and solving for x. So the way I would do it, let's just do this piece by piece, is add 1 to the left side, and instead of just dividing by 2, I'm going to divide each piece by 2. Or in other words, I'm going to write that x is equal to 1/2 u plus 1/2. Divide every piece by 2. And the reason why I like to write the problem that way, integral, I'll move that 1/2 in front, and then I can replace that x with 1/2 u plus 1/2. Trying to color code this. I still have that u to the third power du. I can distribute all these pieces in. Now, if I wanted to, I could also factor out a 1/2. I just don't really feel like it. But anyway, we are about ready to solve this. We're looking at 1/4. U to the first times u to the third is u to the fourth power. And then plus 1/4 u to the third power du. And now we can integrate that, which is adding 1 to your exponent multiplied by the reciprocal. 1/5 times 1/4 would be 1/20. Plus u to the fourth multiplied by the reciprocal of 4. There's a 1/4, so it's 1/4 times 1/4 is 1/16. But just like before, if we started with x's, we need to end with x's. So I replace my u's with 2x minus 1. And that should be your final answer. And I like the way I do it more than the person I'm using these notes from. But if you want to see, this is what I was talking about, is that you can pull this 1/2 times 1/2 because it's just a constant in front. But he ends up distributing it in anyway, so there's really not a benefit to doing it that way opposed to my way. And I believe we have one more example. And then, as I mentioned before, I want to show you number 10. So the inner function would be that x plus 4. So then du, whoops, I guess they wrote down du down here. I like to do it underneath. I don't really have an opinion. So then as I go to the exercise, I can look at this just the way I would have before. I'm looking at 2x plus 1. I'm going to go ahead and write over the square root of u. And then dx is actually equal to du. But I have x's and u's in my problem, so I need to fix that. And maybe what I'll do at the same time is just take that x out, but also rewrite the square root of u as u to the 1/2 power, but don't forget, because it's in the denominator, it's the negative 1/2 power. So then going back to solving for x, well, just subtract 4 over. So x in that problem needs to equal u minus 4. And before integrating that piece, it makes a lot of sense to simplify as much as possible. So we're looking at 2u minus 8 plus 1 would be minus 7. If you distribute that u to the negative first power in there and add the exponents, so it would be u to the 1/2 there, u to the negative 1/2. I hope you're following along with how quickly I can do this. Otherwise, take it piece by piece and see if you get the same thing. Add 1 to your exponent. Multiply by the reciprocal. Well, 2/3 times 2 would be 4/3. Add 1 to your exponent. Multiply by the reciprocal, which is 2 times 7 would give me 14. Don't forget about plus c. And then go back and replace u with x plus 4. So looking at 4/3. X plus 4 to the 3/2 power. And you may want to hit pause, see if you understand, you can follow along and get this. And for the sake of trying to help you out, you might work it out slightly different. Something like this. Essentially the same work, but you can hit pause and follow along. Now you should be ready for the homework. But as I promised, I wanted to talk about number 10, because if you notice, this is a definite integral right here. And this is how they write the problem on the test to make sure that you are doing u substitution without a calculator. Well, this would be on a no calculator test, because it wouldn't be any rhyme or reason really to just look at this problem and say, oh, well, this answer is clear. Like, if you use the calculator, you can get the answer right away. So this is a lot of times on a no calculator test. Now here's the other piece that tends to be confusing to students, is that they understand this piece, that u equals that. So they'll even tell you to let u equal the square root of x, which is x to the 1/2 power. But then students get confused. Well, which one of these pieces is equal to u? Well, let me walk you through which one is better. So if you solve this, it would be 1/2 x to the negative 1/2 power dx. Remember, these du's, dx's are saying what your independent variable is. So just as a reminder, that means that that's 1 over 2 square root of x. So as I solve for dx, what we really are doing, multiplying that over. So as I look at this problem, it would make sense then that is equal to leaving e to the u over the square root of x. I did not give myself enough room. Let me scoot this over. I'll worry about the bounds here. Didn't change colors again. There we go. That you leave the e to the u in the numerator leave the square root of x alone, and then replace dx with 2 root x du, and then you can see that the denominator will cancel out. Now, I mentioned before I didn't mess with the bounds because these bounds were in terms of x. So if you were to plug 1 in for this x, the new bound is the square root of 1 for u. So this bound is still 1. But if I plug in 4 in right here, well, the square root of 4 is 2. Everything needs to be in terms of u when you do u substitution. So as you look through your options, A, it's not 1 to 16. It's not 1 to 4. You have to change your bounds when we change it in terms of u. And it's not E. And as you look at everything else, algebraically, it makes sense that that 2 can be moved in front. Not that one. I don't know why I almost circled that one. Option C is the correct answer. At this point, I can't think of anything that I'm missing here. So I walked you through enough of u substitution. I did this problem because I didn't have any problems in the notes that did definite integrals, where you have to change the bounds when you do u substitution. So write down any questions you have, come to class, ask questions, and you go ahead and do the homework.